Hello everybody, welcome to the Henstitute, in which I'm going to go through the analysis for our projectiles at an angle lab, Comet Man. So those that collected data for Comet Man, but you've missed a couple of days or just need a reiteration of how to analyze everything, this will make it a little bit easier. So the first part, we had Comet Man basically on some surface and you launched him straight up into the air. So the idea is he's going to come out of the cannon, travel up into the air, and then come flying back down. What we're trying to find out is what his initial vertical velocity is. So that's our ultimate goal down here. To do that, I need a couple of measurements. One of the measurements needs to be what I referred to as the starting height. So how far is it from the base of the cannon up to this little pivot point? So this is what I'm calling starting height. This little distance right there, that's my little SH. This little number right there. The other part that you probably measured is how far it is from the bottom of the cannon all the way up to the maximum height. So this is what I'm calling maximum height. That's these numbers, maximum height. Now some people actually did measurements a little bit differently, so you might be a little bit different from what I have, but really what I want is I want Y. Y is the average vertical displacement. That's going to be from this pivot point up to this maximum height. This is going to be Y. And so if you have a maximum height and you have a starting height, you're going to take the difference between those two. So you take the average minus this little starting height, and that would find this Y value. So that's the reason why it's in there. The reason why we need this Y value is in order to find VIY, we know when Comet Man gets up to this highest point, he's going to have a velocity in the Y direction that's 0. So we can use that to our advantage, and I can actually find this using this lovely equation, the fact that VFY squared equals VIY squared minus 2 times G times Y. But since VFY or VY at the highest point is 0, this part will disappear. It means that these two parts have to equal each other. To get rid of that square, I have to square root the other side by square. And then what I have is a great little way of finding how fast something's moving vertically if I can measure the maximum height of it. So if I can measure this Y value, this average vertical displacement of it. And so that's how we're going to find that VIY right there. You should find out that Comet Man gets launched somewhere around 4 meters per second. So you got to make sure everything's in meters. That was tip number 1. That's test number 1. I'll come back to it. Hopefully you can pause the video at any time and look at that part. Test number 2 is a little bit different. We actually have Comet Man up on some surface, and we're going to launch him across the ground. So here's Comet Man. We're launching him horizontally. So this time he's going to come out of there with a VX or a VIX, and that's what we're going to try to find. But in this case, he's going to travel horizontally and splat somewhere on the ground over here. You should have measured that. That is your horizontal displacement. So your horizontal displacement, this is X. Is this average? So all these values are X. The other thing we measured was Y. Y is how far it is from here down to the ground. So this is our Y. This is what the starting height actually is. So we've got X, how far he goes horizontally, and we've got Y. This is actually very similar to our previous lab where we rolled the ball down the ramp and let it come off of here horizontally. We're going to see if we can find out what this horizontal velocity is based off of that. So we should have a nice little way of finding it. All we have to do to find this VIX down here is, before we do that, we have to find time. So we're going to have to find the time that it's in the air for. Well, since he's only getting launched horizontally, his initial vertical velocity is 0. So we don't have any VIY, and we have a great little equation for doing that. We took this equation, the Y equal VIYT minus 1/2 GT squared. Since VIY is 0, this part disappears, and we can rearrange this to solve for time. So time was the square root of -2 times your Y, so I'm multiplying by the 2 there, all divided by g. Now the negative sign is to indicate that he's going down. If you put in your starting height, which is just a positive number, then I don't actually need this negative on here, so I'm going to go ahead and just erase it. But I want you to understand that it's normally there from the equation because he's going to be falling down. But for what we need for time, we'll just put in the positive answers. Take 2 times your starting height, divide by gravity, square root it, boom, you've got time. You're probably going to find your times are somewhere in the 0.4 second range. And then to find Vx down here, all we should have to do is use the fact that Vx or Vix is going to be equal to your horizontal displacement. So you're going to take the average of this number divided by that time. So you're going to take this time right here, and that should find that Vx for you. You should find that the Vix and the Viy you had before are pretty close to the same, and they should both be somewhere around 4 meters per second, maybe a little bit higher, maybe a little bit lower. Kind of depends on your setup. So that's test number 1, that's test number 2. My ultimate goal of this with my analysis right here is to see how close they are to each other. And so to find a percent deviation, what you actually do to find percent deviation is you take the difference between the numbers. So you're going to take your test number 1's Viy minus your test number 2 Vix, and you're going to take the difference between them. Now we usually do an absolute value, so I don't worry about which one's larger and smaller, I just find the absolute value. And then on the bottom, you're going to take the average of those two numbers. So on the bottom, you're going to have your Viy from test number 1 plus your Vix from test number 2. You're going to add them together, divide by 2, and that's what's going to be on the bottom. This number is actually going to be used later. So this is the average velocity. Average velocity of Comet Man. We were just using vertical and horizontal to find it. Take that lovely answer and multiply by 100, and you've got percent deviation. You're going to need this average velocity later. So a little bit later in test number 3, at the very end, it's going to mention right here that they want the average initial velocity. So you're going to take the Vix from part A and the Viy, or the Vix from test 2 and the Viy from test 1, and find the average, and that's going to go in here. So if you calculate it and put it in here, you can have it later. So that would be your Vi later. So that's pretty much all test 1, 2. That's actually old stuff. Test number 1 is what we did when we were finishing up chapter 2 with vertical motion. Test number 2 is the beginning of chapter 3 on horizontal projectiles. And then test number 3 is the new stuff. This is now launching at an angle. So in this case, the first thing I had you do, if you imagine your cannon kind of like this, you had to make 2 measurements. You had to do the starting height, and you had to do the length of the cannon all the way to the ground. What that allowed us to do is actually make this nice little triangle here. So you are looking at this triangle that goes from here up to here and then down and then across. Actually, let's make that a little bit bigger. So you're looking at this triangle right here. Ultimately, what we want to actually find is this angle over here. So I want that angle right there, and to find that angle over there, this is theta, what I can think about is it's going to be the starting height over the hypotenuse, which is the length of the cannon. I should be able to use the sine of that angle is equal to my starting height over the length of the cannon all the way to the ground. So I have my starting height, I have the length of the cannon. Now where am I going to put that in? So on the next page, to find, I don't want the sine of the angle, I actually want the angle itself. So I have to get rid of sine. The opposite of sine is the inverse sine, or the arc sine. So we're going to take the inverse sine of your starting height over the length of the cannon all the way to the ground. Starting height is going to be smaller than the length of the cannon to the ground. Therefore, you're going to be able to take that inverse sine. Make sure your calculator is in degrees so you can actually measure the angle in degrees. Otherwise, if you're in radians, it's going to give you radians, and then you're going to get funny answers. The other thing that you have is you actually measured on average how far he went. So this is our measured X. That's our experimental. What we're going to do is we're going to actually go through in analysis number 2 here. How do we actually calculate the horizontal displacement? So we're going to have a calculated X. This is going to be the theoretical, and we're going to eventually find the difference between those, or how close they are. So percent deviation is actually going to be the difference between those two values over the average of them. But how do I find this X calculated? So to find this X calculated, we have a brand new equation. I just finished up with the notes, the one that says finding velocity, develop this equation. We'll talk a little more about it. But to find this, you have to take 2. You're going to multiply by this initial velocity squared. So make sure you're squaring that initial velocity. Then you're going to multiply by the cosine of your angle, and then times the sine of your angle. All of that stuff is going to be divided by little g. It's going to be divided by 9.8. And that should calculate how far Comet Man should have traveled. I think those two numbers should be the same. In other words, this calculated one and this measured one should be the same. I want to see how close they come. So the percent deviation down here for this last one, you're going to take the difference between your measured X and your calculated X, absolute value it, because I don't really care which one's bigger or smaller. And then on the bottom, you're going to have the average of those two numbers. Since I don't have an accepted value, you're going to take your measured X plus the calculated X over 2. So whenever you're doing deviation, we have to use an average because we don't actually have an accepted value. So it's just a lot of calculations once you get all that data. The reason why I do the Comet Man this way and I don't have questions like what are sources of error and how to improve them is I know what the source of error is. It's the measurements of distance, measurements of displacement. Those are just hard to actually get, so we just kind of skip over it. I hope this helps in how to analyze all the stuff with Comet Man. Please pause the video anywhere you need so you can catch those pieces. I've got equations up there and you should be good. Hope you enjoyed this little edition of the Henstitute.